I've always been told sharing is caring. Even though I don't fully believe in sharing food, if I'm eating in front of someone, I'm going to have to share. Like the time when I was about to devour my favorite chocolate bar and my friend came up out of nowhere. Okay, I'll share. I have 4 chocolate sticks in one packet of chocolate. That's plenty to share. If I share it equally, then both of us will get 2 bars each. So basically, for every 2 bars I have, my friend has them too. This relation can be expressed as 2 bars to 2 bars. Mathematically, we would call this 2:2, where the term ratio is represented by this notation, the colon, and is used to represent the relation between 2 quantities of the same kind. But what if I had been a little too greedy and hoarded 1 extra bar for myself? What will the ratio of my chocolate bars to his be then? Think about it. For every 3 bars I'd have, he would have 1. 3 bars to 1 bar, or 3:1. Good. Let's say the tables have turned and my friend is now the needy one, asking for 1 more stick on top of the 2 he already has. What will the ratio of my chocolate bars to his be now? Right, 1:3. You see, the order of the ratio matters. 1:3 is not the same as 3:1, not at all, especially when chocolates are involved. Oh, and on a side note, ratios can also be written in the form of fractions. So, 3:1 can be written as 3/1 as well. Just how 1:3 can be written as 1/3. Okay, enough about chocolates. How about something healthier? Maybe apples and oranges? Could they be compared? Well, since they're both fruits and ratio is a comparison between the same kind of quantities, yes. So, if we have a fruit basket with 6 apples and 9 oranges, then according to what we have learned so far, the ratio of apples to oranges can either be written like this, or even this. What about your TV screen? Its width and height, being similar kinds of quantities, can be compared too, right? They sure can. And while we're at it, let me introduce you to some pretty cool terminologies. Let's say 4:3 is the ratio representing the width of a TV to its height. Then this part, which is the first term, is called the antecedent, while the second one is called the consequent. Speaking of the consequent, do remember that in a random ratio A to B, this B, the consequent, can never be equal to 0. How can you forget? Now that we've covered so much about ratios, solving an example would be a piece of cake for you. Here, we have to find the ratio of 200 grams to 700 grams. The first step is to write it mathematically by putting a colon between the 2 quantities, then as a fraction. Once that is done, we can simplify. Not just the numbers, but the units get cancelled as well. See? This is why ratios have no units. Anyways, you're left with 2/7. Converting it back gives 2:7. Now, this final ratio is just the simplest or lowest form of the given ratio. One more example should drive this point home. Notice how both quantities are of the same kind? They're both distances, but their units are not exactly the same. To resolve this issue, the first step we carry out is to convert the quantity in kilometers to meters by using this relation. Replacing this, our ratio becomes 1000 meters to 600 meters. You know the drill from here. Write it as a fraction, simplify, cancel the units, and it gives you 5/3, the simplest form. So, we can write it as 5:3. This was just an introduction to ratios. They're very important. Never underestimate their practical importance. If, God forbid, the ratio of rice to red chili isn't perfect in your biryani, you could either burn your mouth from the spiciness or your biryani could turn out bland. I don't know what's worse.